Thanks. You'll have to excuse me, I have a slight cold, so I may be sniffling and coughing a bit. That shouldn't be too big a problem, though. My name is Mørk, and I work as a Java developer at Opera Software. I work on the Opera Mini web browser for mobile phones. Today I'm going to talk a bit about the browser itself, the technology behind it, and the biggest problem that most Java Micro Edition developers are facing today, which is the fragmentation of the market. There are lots and lots of different phones out there. They all have different features, different amount of resources available, and that's a huge challenge which we are trying to solve, and I think we do a pretty decent job about it. So, first of all, the Opera Mini browser. Is there anybody here who's tried the Opera Mini browser? Great. For those who haven't tried it, well, there are two ways to explain what it does. There's a short way and there's a long way. And the short way is that you point your web browser to this address right here, mini.opera.com/asm06. And you can download the application. It's totally free. It's a Java application, and it should install on almost any handset out there, at least the ones made for the last 3 or 4 years. And you can try it for yourself. It's based on the same core engine as the Opera desktop browser. It's a server-client solution, which means that we have this proxy server running. Well, actually, it's several physical servers, but you can view it as a single server that fetches the page you request, then it reformats it, strips out all necessary stuff, removes pop-ups, things like that, resizes pictures, and compresses it all into a very efficient binary stream that it sends to your phone, which then renders the page. We use Opera's SSR, small screen rendering system, on the server, and then it's sent totally binary. So we use a format similar to HTML, but it's totally binary and very, very efficient. So you'll probably see that a web page that could be like 500 kilobytes on your desktop browser is reduced to perhaps 40, 50 kilobytes on your handset. So it's pretty fast, pretty effective, and it saves you a lot of GPRS cost. So the mini browser basically comes in two flavors. It's a mid-P1 flavor and a mid-P2. Anybody here ever tried writing anything in Java Micro Edition? No? Anybody familiar with Java from before, in other circumstances? No. Java Micro Edition is basically a subset of Java Standard Edition. And quite a few things are missing, like the whole swing AWT stuff is gone. It has a proprietary, well, it has a totally different system for laying out user interface stuff. It does not have floating point instructions. Well, basically a lot of stuff is lacking, like file access, stuff like that. And the the mid-P1 is the first version of Java Micro Edition, and then they found out that there were probably a lot of things they forgot when they made the first edition. So mid-P2 has quite a few more features for customizing the appearance of your application. You have more control over the soft keys on your phone. You have better drawing functions, stuff like that. So mid-P2 is basically the newer, more powerful phones. Mid-P1 is the older phones. So quite a well-known example of a mid-P1 phone is the Sony Ericsson T610. And basically everything that's been made for the last few years is mid-P2. Now, these two binaries together run on more than 400 different handsets. And I don't know if any of you have worked in the mobile entertainment industry. You see when people make Java games, which are quite popular, like the ones a few euros and you can download a football game or whatever. They usually deliver maybe 30 different builds to the service provider, so he can resell these jar files. We have one build for each version of the Java Micro Edition. Of course, that introduces quite a few challenges, namely the fragmentation of the market. lots and lots of phones exist out there, and they all have different feature sets, different screen sizes and stuff like that. So first of all, I'm going to talk about the different bugs out there. Every manufacturer, of course, has quite a few different models of phone, and also they have different generations of the implementation, like Sony Ericsson, who has their Java platform, which is now up to version 7. And they fix a few bugs between these platforms, they introduce a few new ones. So basically you can't assume that every Nokia phone will behave similarly, or every Sony Ericsson phone will behave similarly. Sometimes they also release new firmware versions where they fix a bug and perhaps introduce a few new ones. Now, you might think that, okay, I don't want to sit down and test every single phone. I can just download the emulators. The problem is that the emulators available for mobile phones today, or, well, you run them on your desktop computer, but they emulate mobile phones. They're quite imprecise. A good example is the Sony Ericsson emulators, which are basically the standard Sun wireless toolkit emulator with different skins to resemble different Sony Ericsson phones. So more or less the only thing in common with the real handset is the screen resolution and the skin you see on the screen. So you can't assume that if it works on an emulator, it will work on an actual handset. And that's what a lot of people find out when they write their first Java Micro Edition applications. Everything runs fine on the emulator, and they use a huge amount of memory, and they probably have a pretty slow code, but it looks great on their PC, and then they try to run it on the handset. And they find out that, oh, I don't have enough heap memory, or this is slow as hell, and stuff like that. Also, another problem is that although the Java Micro Edition mid-P1 and mid-P2 profiles are quite clearly defined, a lot of manufacturers don't actually follow the specifications. There are small variations. For example, system property strings, stuff like that. They usually have small deviations from what you should expect from the specs. So what we had to do about this was actually getting a lot of phones. A lot of phones. You can see a few of them in this image there, but that's just a small part of all the handsets we have available to our developers and QA personnel. And we had to test the phones, find out which bugs they have. Of course, we have, when we release a version of Opera Mini, pretty soon we'll get bug reports from people who report a new bug in the handset. And of course, I'm not claiming that Opera Mini is totally bug-free, but quite a lot of the problems we're seeing is bugs in the implementation from the manufacturers. And since we can't really fix those bugs, we have to work around them. So what we do is we find out which models have which bugs, and as Opera Mini starts up, we try to detect what handset are we running on now. Okay, which known bugs do we have for this? Which workarounds do we need to enable in the code? Another difference, huge difference between the handsets is the available resources. You have different screen resolutions, you have different color depth on the screen, RMS storage. I don't know if you're familiar with that, but that's Java Micro Edition's idea of persistent storage. I think RMS stands for Record Management Store, which is, well, you can put bytes in the RMS, and next time you load up the application, you can take the same bytes out of the RMS. If you're lucky, if the handset manufacturer has implemented it properly. Also, the available heap memory varies considerably. Some of the first Nokia Series 40 devices have something like 200 kilobytes of available memory, and with the Java application, you're going to use that pretty quickly. And if in addition you're going to hold a web page in memory, and quite a few images, stuff like that, you're going to run into memory problems pretty quickly. The jar size, the maximum jar size also varies. Quite a few of the early mid-P1 handsets have a limit of, well, you should think that it's 64 kilobytes, and they claim that it's 64 kilobytes, but it's not. It's definitely not 65,536 bytes. I think that the Nokia Series 40 handsets have a limit of 62.5 kilobytes or something like that. It might be 64,000 bytes though. Anyway, that imposes quite a few restrictions on us. And for example, the two phones you see in this picture here, the 3510 I think, which is the last Series 30 phone from Nokia, color Series 30. It has a display of 96 by 65 pixels. Now, the Sony Ericsson phone, the K700, which is 2 years old now, or something like that, has 176 by 208 pixels, which leaves you with quite a lot more screen real estate. Now, basically, we want the same binary to behave as similarly as possible on these two devices. But we have to write code that works on the lowest common denominator. That means optimization of code size, of memory usage. And another thing that we do at startup, we try to find out how much available memory do we have. Because although we can ask the system for how much memory is available, you can't always trust the values you get back. If you think, okay, the available memory method returns, what, 100 kilobytes, then we can safely allocate 100 kilobytes. Well, you can't in many situations. You'll get a memory out-of-memory error. So there are different ways of doing that, and you can try, for example, allocating more and more memory and see when it stops. Also, the RMS storage and usage of heap memory. Since this is Java, we will hopefully get exceptions before we get a total crash of the device. And what we need to do is handle those exceptions. For example, if we load a page in Opera Mini and suddenly we get an exception, we're running out of memory. Well, then it's probably time to clear the image cache, clear the previously visited pages cache, stuff like that, and try to see if we can continue. And what you'll sometimes find out, especially on a low-end phone, when you run Opera Mini, you sometimes get a message that you're out of memory. Now, that shouldn't happen, because we should partition the web pages into chunks that are big enough to fit in the memory of the phone. But, as I said, sometimes the available memory is misrepresented by the handset. Another good technique for fitting in the maximum jar size is obfuscating your code. Not only does that make it harder for other people to decompile your program and steal your code, but it also makes the jar size quite a bit smaller by shortening all variable names, removing unused method calls, stuff like that. So you can get quite a nice jar size reduction by using a good obfuscator. And of course we have the optimization techniques that you can probably read about on most any J2ME development site, like using a lot of static members, using as much code reuse as possible, and of course a number of classes as possible. Now, that's not necessarily compatible with good object-oriented coding standards, but it's things you will probably have to do to make an efficient and small Java Micro Edition application. Now, another problem is, of course, the different implementations, because Java Micro Edition runs on quite a few different handsets. For example, the two phones displayed here, the Nokia 6230i, and I think that's a Q-Tech 9100. Although they're quite different beasts. I mean, you have the PDA smartphone at the bottom, and you have the normal mobile phone at the top. But both of these are running Opera Mini. They're actually running the same version, and it looks quite different. What you'll find is that on the Windows mobile device there, for example, you don't have soft keys. You have soft keys on the keyboard, but they're not available for the Java implementation. And since Opera Mini relies quite a bit on soft keys, we had a problem. So what we do is, on the QWERTY keyboard, we have the Q on the far left and the P on the far right, and we use those as soft keys instead, left and right soft key, to bring up the menu, stuff like that. And actually we wrap the whole key press code in a method that translates into a few well-defined key codes that we actually use in the application. So that's also something we have to do. Check out a lot of mobile phones, see what key codes they deliver, and what we can translate it to if they're missing keys that we really need. For example, the left and right soft key. Fire key as well is used a lot. We use it to select links, stuff like that. And of course, different phones might deliver different key codes for what you should think was the same key. Another thing is the APIs that aren't part of the J2ME core. For example, the wireless messaging API, which we use for sending SMS. We have a feature in Opera Mini that says recommend to a friend, which sends an SMS to a friend with the download link for Opera Mini. Now, not all phones actually support sending SMS. For example, it might be a device made for a market that isn't based on GSM. For example, American CDMA phones. I won't swear on this, but I think quite a few of those don't even have SMS functionality. So we have to try to detect which APIs are available on this phone. So that's also part of the detection phase. See what kind of phone this is. Do we have the classes needed to send SMS available or not? So what we do, what you'll probably find is that if you include code that references an optional class from an API, like for example the wireless messaging API or the camera API, stuff like that, you'll find that if you include code like that in the main classes of your application, it won't run on several phones that don't support those APIs. So what you do then is you put all the API-specific code in a wrapper class. For example, let's say you have a camera functionality class where you put all the camera stuff in there and you query the device and startup. Do you have camera functionality? And if it has, you can safely load your wrapper class and it won't crash. If it hasn't, then you never load this wrapper class you made and you will avoid the crash. Now, there's another approach to doing this. As I said, we have 2 builds for almost all Java phones available. But as most Java game developers do, they have a build, for example, they'll have a build for all Sony Ericsson phones of a specific generation and screen resolution. The problem is that if you have to make, for example, 40 different builds from the same code base, that's quite a job to maintain. You need, definitely you're going to need some pre-processing on your code. Of course, we also use that because we have the 2 MIDP1 and MIDP2 editions, but still, we have 2 different versions to maintain. If you have 40, it's starting to run into maintain a build a nightmare. And also, if a new model comes out, you might have to rewrite large parts of the code. And for us, usually the code will run on most new phones that arrive because we're using pretty standard stuff. What we do is adapt the functionality and requirements of our application to what's available. Another problem with using custom builds is, of course, the delivery over-the-air installation for mobile phones. You can try using a server that detects the user agent of the phones that access your site via web, but it complicates stuff. And also, if you want to distribute this, then you have another problem, because you have to say to the guy who distributes the application for you that, okay, here are 40 builds, and here's a matrix of different phone models, and which builds run on the different phone models. And that's quite a big job. For us, we can say, is it a MIDP1 phone? Well, we can query that from the phone, the supported MIDP profile. We can give them MIDP1 if it's a MIDP1 phone. or mid-P2 if it's a mid-P2 phone. Easy as that. So that's one of the biggest pros of having only 2 builds for different profiles. But still, custom builds could be good for games and stuff like that use a lot of pre-scaled graphics, for example. And games usually do that because the sprites and background stuff like that will only look good at a certain resolution. So probably most game developers will continue using different jars for different handsets, but I think that our approach is probably the best for serious applications. To sum it all up, how we deal with the fragmentation in the market is, first of all, we have to test a lot of phones. And that's one of the good things about having such a big company with a specific QA department. We can get them to test phones, find out what works, what doesn't, and then they can notify the developers if there is a problem phone. Of course, then we'll have to take this phone, look at it, see what's wrong, what works, what doesn't work. The most important part of our compatibility is the detection phase at startup. Now, the problem is that some phones can be quite hard to detect. Normally, you should be able to, you have a Java microedition called get system property. And the system property microedition.platform should, in most cases, tell us what kind of phone we're dealing with, but often it doesn't. It could return, well, sometimes it doesn't return anything. It could return a useless string like J2ME. I mean, we already know that we're running on a J2ME device, so you don't really need that information. And if we can't detect by that way, then we have to do it in some other way. One thing is looking for proprietary classes. For example, Siemens phones, they have a lot of proprietary game API classes. So we can try loading one of those classes, see if it is available. And if it's not, then we're not running on a Siemens. If we can load the class, then we know we're on a Siemens. And if we're looking for a specific model, we can narrow down because we know the different screen resolutions and stuff like that. So a combination of properties in the phone is useful for finding out what kind of make and model we're running on. Another important thing is keeping the optional APIs in separate classes to avoid crashing. If your main program class contains lots of calls to, any call really to an API that isn't supported, then chances are good that the application won't run at all. And of course, also writing wrapper code. For example, alpha. Some displays support 8-bit alpha. Some only support full transparency or full opacity. We have to, if we have, for example, we draw a few shadows in Opera Mini, we have to have wrapper code for that and try to find, well, can we do some blending and have a pre-made bitmap that contains the shadow and the background color, or do we have to drop the shadow totally? Yep. So, anyway, now I want to know if you guys have any questions. I'm sure there are a lot of topics that I haven't covered yet, and well, if there are any J2ME developers or would-be J2ME developers out there with questions about compatibility and performance on the different handsets, then now's the time to ask. Yeah. That's true. The mid-P3 spec is under development, and probably we will make a new build for that. One of the problems right now is that we're starting to, well, some mid-P2 phones have a max jar size of 100 kilobytes, and we're starting to push that boundary. So we might have to make an even bigger and more feature-packed version of Opera Mini. And well, of course, we will support the new stuff in mid-P3 when it arrives, but I think that market penetration of mid-P3 phones is quite a long way from now. Mm-hmm. Yeah. Yeah, that's true. The proxy server runs an instance of the Opera browser for you on the server, and it also stores your cookies on the server. So your client on phone has a unique ID, and it reports this ID to the server. And it says, okay, this is that specific client. Let's fetch all the cookies.
So it's all the content scaling done on the server side?
Yeah, it is.
Okay.
So we're using, well, for the phones that support it, which is almost all mid-2 phones, we use JPEG compression on all the images. We have our own JPEG decompressor written in Java that.
So it basically queries your resolution.
Yeah. Well, when the client makes a request to the server, it has most of the client capabilities in the request. So the server knows, for example, color depth, of course, which profile we're using, screen resolution, stuff like that. Yep.
The civilian versions of Opera also use the proxy.
Sorry?
Does the civilian, the x60 versions
Oh, well, Opera Mobile does not. That is a standalone browser running on the phone. But you can run Opera Mini on Symbian as well. And, well, they have different uses, really, because sometimes you need the full web access on your Symbian phone, and that's when you can use Opera Mobile. But if you need some quick surfing and you want to save on costs, then Opera Mini is great. It does not preserve most of the layout you see on a page. So, but what it does do is compress the pages significantly, so you can save on GPRS cost. So, of course, as an Opera representative, I will recommend getting both applications on your phone.
So, are you logging all my porn?
Just the good stuff. We've been throwing the rest away.
It's all good.
Now, I'm afraid we don't log your porn, but we do look in on it from time to time just to see that it's nothing illegal. Sorry? Yeah, well, the only thing we really contain is your cookies. And of course, we don't go and look at your cookies. So one issue is, of course, the security, and that's something quite a few people ask about. Encryption between the device and the proxy server, which is, at the time being, non-existent. There's encryption between the proxy server and the page you visit, so that can be sniffed. But if somebody is sniffing your GPRS traffic and they have a decoder for our binary format, they can see what you're visiting. But privacy on the server is ensured because, oh, we don't snoop. Any more questions? Yep.
About the encryption, if they're going to be free, for example, I don't know on which level the...
Yeah, well, what we need is to encrypt the socket connection from the client to the server. And we're looking at a few different approaches to that. One of the problems is the different certificates installed on phones. And on most consumer handsets, you can't install new certificates. So we have to support the ones that are already on the phone. But we want encryption, and we're working on it. It's not available in the current version of Opera Mini, but we're definitely going to get it sometime in the future. Because we want to have encrypted traffic all the way, so people can be safe when they do their banking and stuff. Now, personally, I've done a lot of banking operations on Opera Mini, but it's not really 100% safe. But then again, I doubt that people are sniffing Opera Mini traffic over the GPRS link. That's me, just me though. Yep.
I mean, since you're considered good guys, people tend to trust you for having this kind of proxy thing. But if you'd be Microsoft, then people wouldn't be.
Yeah, well, if we were Microsoft, I wouldn't trust us either.
But do you have any plans for PR? I mean, to keep people trusting you?
Well, that's it basically. I mean, since we're not doing any shitty stuff with your data, then nobody's ever gonna catch us doing shitty stuff with your data. So, as long as we don't fuck up, I hope people will continue to trust us.
You can't ever prove that we're not doing something bad, right? So,
As long as we don't catch you, it's okay.
right. Well, effectively, the way trust really, really works is you say, well, these guys seem to be reliable, and
He doesn't seem to screw my girlfriend.
right, and
Yeah, definitely. We get new users all the time, and it's well, not too long ago we crossed 4 million downloads of the application, and we're seeing a constant increase in page downloads and people installing Opera Mini. And of course, we hope that the people here at Assembly will try it out if they haven't already. As I said, miniopera.com/ASM06 with a special limited edition Assembly skin. And of course, a few important shortcuts to like the schedule, poets, so you can check out the comments on the demo scene releases, stuff like that.
So just to follow up on that, MIDI is seeing a lot of uptake actually in the developing world. One of the interesting things is that you sit around here and you've got high bandwidth connections everywhere you go. You've got a lot of desktop computers. You've got a PowerPoint you can plug them into. All of the infrastructure is pretty good. In a lot of the developing world, power is an issue, connection is an issue, bandwidth is an issue, being able to share the machine around is an issue, and that's actually a place where the mini browsing model is going really well. And they're like just amazing.
Any other questions? Okay, then once again, I want to plug the fact that we are actually hiring people now. We want new colleagues. If you want to work on the Opera Mini project or any other Opera project, you should check out www.opera.com/jobs, or you can come over to our stand and have a chat with us. I'm sure that most talented people are people that we want. Yes?
Does it require one to move to Norway?
It does require moving, but we do have offices in other countries as well. We have Swedish offices. You can move to India, San Diego, Japan. I mean, we have offices in quite a few places all over the world, but we do not yet have a Finnish office. I'm not making any plans here now. But I can say, well, as a Norwegian, of course, I would say that I like working in Norway, but we have an Australian here who doesn't seem too unhappy about living in Norway. We have people from 35 different nationalities working at Opera, and it's quite an international company. English is the working language. If you go through a canteen, you can hear people talking in lots of different languages and English. It's a very including environment, and anybody would really fit in there. If they have the right motivation and the right talent, then are definitely people that we want at Opera.
So I have to say, I wouldn't work at Opera just so I can live in Norway. But I do live in Norway just so I can work at Opera. So Norway's not bad.
That's true. Well, working at Opera is of course the main carrot, but you also have the added bonus of living in beautiful Oslo, which is my birthplace. So if there aren't any questions, I want to thank you for listening, and I hope to see you at our stand.